Hi everyone, we have got a microeconomy question today where we have been asked to consider a utility function for these two goods x and y, and from that utility function we are asked to find the Marshallian demand function for both good x and good y. So basically what Marshallian demand is, we ask ourselves how do we maximize our total benefit or total utility for a given income. So the optimization problem maximize utility is equal to xy subject to m, which is equal to price of x into unit of x plus price of y into unit of y. To solve this problem we have to use Lagrangian multiplier. So L is equal to objective function, which is xy plus lambda into m minus pxx minus pyy. Here we need to put first order condition with respect to x, y and lambda. First order conditions are that the partial derivative of Lagrangian function equal to 0. So del L with respect to x is equal to, from this we can get y, and from this we can get minus lambda px is equal to 0. That implies y is equal to lambda px. This is our equation 1. Del L with respect to y, from this we can get x, and from this we can get minus lambda py is equal to 0. That implies x is equal to lambda py, which is our equation 2. Del L with respect to lambda, from this we can get 0, and from this we can get m minus pxx minus pyy is equal to 0. Equation 3. So by dividing equation 1 and equation 2, we can get y by x is equal to lambda px divided by lambda py. That implies pxx is equal to pyy. X is equal to pyy by px, and y is equal to pxx by py. So here we can get the solution by putting the value of x and y in equation 3. So m minus pxx minus pyy is equal to 0. By putting the value of x we can get m minus px into pyy divided by px, which is the value of x, minus pyy is equal to 0. M minus pyy minus pyy is equal to 0. That implies m minus 2pyy is equal to 0. That implies m is equal to 2pyy. So y is equal to m divided by 2py, which is our Marshallian demand function for good y. Similarly, by putting the value of y, we can get py into pxx divided by py. That implies m minus px minus 2pxx is equal to 0. That implies m is equal to 2pxx. That implies x is equal to m divided by 2px, which is our Marshallian demand function for good x.